You have finished chapter 2, and you've gotten some good experience in problem solving. Now we're going to move on to chapter 3, where you're going to learn how to quantify properties of substances in order to identify the state of the substance. So let's go ahead and get started and sort of overview what's getting ready to happen in chapter 3. So the title of chapter 3 is Evaluating Properties. And you can think of this as quantifying properties. And it's really going to pay off for you as you teach yourself to become a practicing engineer. So let's look at a roadmap of what's going to be covered in chapter 3, and it's a lot. And what I've got circled here is what's covered in this module. I'm going to talk about pure substances, and I'm going to convince you that you already know a good proportion about phases of substances, and I've labeled that as easy. It's stuff you already know, have a feel for. I've labeled everything else hard because much of it, I think, is going to be some new material to you. It's going to involve some hard work in terms of learning some new skills, and you're going to benefit from them. Another key point to make about chapter 3 is you're going to cover two categories of properties. One's going to be properties that can change their phases, more in just a second, and other substances that we would consider gases that you probably have some familiarity with already. And so the purpose of chapter 3 is to introduce concepts and skills to enable you to quantify properties of substances in order to identify the state. So remember that. So a set of properties defines the state. And also, in your homework assignment, you're going to be putting it all together. You're going to gain practice in using the first law of thermodynamics and engineering problem solving and evaluating property values for the substance you have on each specific problem. And so remember, I've tried to depict in a cartoon, remind yourself that, okay, I might have some substance contained in a box here at state 1, and it's going to go through some process to get to state 2, and something will have changed. The state will have changed. And this little screenshot here is an example of a pressure specific volume diagram it may look Greek to you. It may look confusing. I'm going to introduce that to you, as well as your textbook, of course, does a great job of introducing this pressure volume diagram as well. Okay, so let's just do a little easy example. Can you identify what this substance is? And we're going to, this is going to be your intro to phases and pure substances. Okay, so let's look at those images and see if you can identify what would you call the substance identified in those images? And of course, the answer is a bucket of water. Here's a tub of ice, a pan of boiling water on the stove. And what's coming out of these pipes that's coming out of from underneath this vessel, it would be steam, right? And wait a minute, I'm not really seeing steam, and that's correct. You are seeing a cloud, so that's sort of steam that is condensing back into water that you can see with your eyes. Steam you can't really see with your eyes. But all of these, what's the important point? All of these are H2O, aren't they? So each one of these images represents the substance H2O. How about phases? And I'm going to suggest that you're already sort of familiar with phases of H2O, aren't you? This water would be called in the scientific term the liquid phase, right? Boiling water. Do you see that with your eyes you can see bubbles? Well, that's not air, right? It's water vapor, isn't it? It's steam vapor. So this is a mixture of liquid and vapor that you can see through the Pyrex. Up here, solid phase of ice. So if you wanted to be scientific about ice, you could say it's solid phase H2O. And of course, the steam, that would be the vapor phase that you can't really see. All right. So the next thing, what is this? What's this substance right here? And let me jump right to you know what it is, and I've added another image here in my answer slide. What's contained in this room here? What's contained in this atmosphere? And you say, well, everybody knows that it's air. Now, you might not know at least the proportions. I think you probably have a pretty good feel that air is a mixture of nitrogen and oxygen and some other stuff, argon and CO2, but you might not be familiar with the proportions, and that's okay. You can always Google it. I Googled components of air, and I got my numerical result. Air is mostly nitrogen. That may surprise some folks. Mostly nitrogen, 78%. Only 21% oxygen. Of course, we need that to live, don't we? We need oxygen to live, and also trace amounts of argon and CO2. So it's for me, it's extraordinarily interesting to see that the proportion of carbon dioxide in the air is really a small proportion. Very interesting. And so here's the pie chart, and you can see the blue slice is the nitrogen. Okay, the third, what is this substance depicted in these images here? Well, the right-hand image is sort of a giveaway, isn't it? And so, but the left, well, that's dry. It's the same substance as what's in this fire extinguisher. The gas phase of CO2 helps us put out fires, particularly electrical fires, where we can't douse an electrical fire with water. CO2 is a very good firefighting tool for electrical fires. Okay, over here, dry ice, pellets of dry ice. And here would be a spoonful of dry ice. And you kind of see that it's sublimating. And I hope you've been exposed to that term, sublimation, where the solid phase of CO2 is transforming immediately into the vapor phase. And here's some little traces, some hints of CO2 vapor here that you can detect with your eyes. So all of these images represent CO2, and they're all the same, right? So chemically, they're all the same. The chemical composition of all these phases is the same, just like air and just like H2O. Last example, what is this? Now you ought to be able to identify this probably with your eyes because you see it's part of a manufacturing process. We're making a square steel rod, okay? And hopefully I don't know if you've had the materials class yet on steel. Steel is a mixture of mostly iron and a little carbon. And depending on the type of steel, there may be some additional elements in there like chrome or magnesium, I think, things like that. But you do reckon, well, what's the phase of this? What's the phase of this steel? It would be a solid phase. And you all realize that you got to get that steel really, really hot to make the phase up, to make it liquid. But those are some examples of things that I think you can identify and you already know about. So you're not coming into this cold. And so it really brings us to the recap. So all of those examples are considered pure substances. And what does that mean? So now we're back to our thermodynamics textbook. A substance is called pure if it's chemically the same, no matter what phase the substance is in. And that's going to be particularly appropriate for our study of H2O, water, steam, and vapor. And so you're going to be dealing with pure substances throughout the rest of this course. And so the comforting thing is that all the substances we're going to deal with, no matter what the phase is, for this class, they're all going to be pure substances. And this is going to be probably consistent with your experience as an engineer once you get out of your out of school, out of your bachelor's level education. So that covers the easy part of chapter 3. That's the easy part. Now, so the next video, we're going to cover pressure, specific volume, temperature, surfaces, and the detailed engineering phases of these phase change substances. So let me encourage you to hang in there and go on to the next video, uh, because it is going to get harder. So chapter 3 does get harder, especially when you start putting pencil to paper to numerically quantify the various properties of these various substances.